first example, you might see this on the ACT test. There are two matrices and there's an equal sign in between. You see how both matrices have the same dimensions. What dimensions?
3 by 3.
3 by 3, 3 by 3. If you look at first row, first column, you get 6. That says 1R, 1C. If you look over here, first row, first column, 6. They're equal. 4 equals 4. Negative 3 equals negative 3. 8 equals 2y. So y is 4. You're going to be asked to find the variables, what they equal. That's what you're going to be asked to do in your homework. So find where the x is. Here's x. What's that equal to? 14. Done. Find z.
Z equals
3z equals 9. So z equals 3. Done. No. So that is what you do if they are equal to each other. That I know when I was actually Googling like ACT question matrices, because I'm curious what kind of questions they ask in the ACT, and that was one that I saw that came up. Next, to add or subtract matrices, the matrices must be the same dimension. To add or subtract, you got to check, are they the same dimensions? So the first matrix is A, and that's a 2 by 2. And it says add A plus B, which is also a 2 by 2. Can I add those?
Yes.
Yes, because they're the same. To add them, you add your first column, first row, first column, with first row, first column. You add together 4 plus negative 6, negative 2. Then you add together negative 1 plus negative 5. Negative 6. 6 plus 7. 13. 3 plus 3. 6. Done. So the matrix that you get in your answer is the same dimensions as the matrices you were adding. Now, when you go to do B, people make silly mistakes sometimes. I personally like to not subtract, but I like to add the opposite. You know what I'm saying? Where you change the signs of B. So I have positive 6, positive 5, negative 7, negative 3, and then just add those to A rather than subtracting. You can add the opposite. You can do either method. You can do subtraction or you can do add the opposite. It does not matter. 10, 4, 1, 0. I want you to try, nope, I'm just kidding. Look at C together. And then you can try D, but look at C. We're going to add matrix B and matrix C together.
No, we're not.
No, we're not, because they don't have the same dimensions. So if that happens, you write undefined. It's not possible, so you write undefined. So if that happens in your homework, don't just leave it blank. Like you got to write something so I see that you know you can't do it. If it looks blank, it looks like you skipped it. Yeah.
You like expand, I mean, or like you can't.
Right. You can. If it's a 2 by 2, it's a 2 by 2. All right. Can you try D? Question D. You try that one. I'll put the answer up. Don't just copy my answer. Try it, and then check your answer to see that you did it right. So you cannot add anything on the same to that. So 2 by 2. Yeah, that's a 2 by 3. All right, questions? Too hard? Too hard, right?
Yeah, I want to stop.
Well, you can, but. Next is called scalar multiplication. Scalar multiplication is when you have one number multiplied by a matrix. We did vectors, like, at a very unfortunate time, which I know you didn't have a lot of time to remember the vectors, but we did them and where we had scalar, where you took a number and you multiplied the vector by the number. It's the same thing. You take this number and you basically distribute it to A. So you get 12, negative 3, 18, 9. That is scalar multiplication. Can you answer B and C? Do it. I will write the answers up for B and C. Please do not check your answer until you've tried it. Did you find this your own or did you copy mine? Okay, so you've already multiplied by the negative. If you put the negative into this, then you're adding them. Okay, that's what I did too. I multiplied by negative 3 and then I added them together. You don't want to do double negatives. It's fine. Your answer. Okay. Great. Questions? So, how exciting is this? You can totally do all of this stuff on your calculator. There's matrix buttons on the calculator, but and I'm gonna show you how to do stuff on the calculator, but it takes longer to do some of this stuff on the calculator than just adding, or like for this question, to type the matrix into the calculator and then do 3 times that matrix. Why not just multiply everything by 3? Like, take way less time to do it by hand. Sometimes. Okay. So when we have a quiz on this, which you'll see on your syllabus, it'll be next Friday, a week from today. There'll be a quiz on the entire chapter. Part of it will be non-calculator, and part of it you can use the calculator on. So you will need to know how to do this stuff by hand. So if you choose to do your entire homework with your calculator, you're hurting yourself because you won't know how to do it by hand. All right. Next section is multiply. Basically, in order to multiply, you have to check the dimensions of the 2 matrices that you're multiplying. There's an example here where if you have a 3 by 2 matrix and you're multiplying that by a 2 by 3, you're only allowed to multiply it if the middle 2 numbers have the same dimension. So you have to check this. Otherwise, you can't multiply if they don't have the same two numbers. And what's very nice about doing this too is after you check them and you say, yes, you can multiply, the other two numbers tell you what your answer matrix would look like. So if I multiply a 3 by 2 times a 2 by 3, I will get a 3 by 3 when I am done. That's what those numbers will tell you. So I'm going to do a few examples. This might take a moment to catch on. It's not challenging, you just have to remember what to do. There is an example totally worked out at the top of your next page, which I didn't copy up here. But we'll just start on example A. We are multiplying what dimension by what dimension? 2 by 2, 2 by 1. So am I allowed to multiply?
Yes.
Yes. What will I get after I multiply? 2 by 1. So I'm going to start, I'm just going to organize my work. I'm going to draw two rows, one column. I drew 2 rows, 1 column. Now up in the matrix, in order to get the first row, first column in the answer, I have to use the first row and then the first column from the two matrices. I use the first row and then the first column. That's how I get row 1, column 1 in my answer. And what I do with those is I multiply 1 times 5. You see where the 1 and the 5 are? Then I add that, and I multiply 2 times 6. So I'm multiplying the first numbers together, then I hit addition, and I go to the next numbers and multiply those together. And I would keep going until I'm out of the row and column. That's why the row and the column have to match. Now to get second row, first column, I do second row, first column. So I do the first number, 3, times the first number, 5. Then I do plus, and I do 4 times 6. That will give me, when I multiply and add those together, that will give me a matrix that is 1739. 2 rows, 1 column. All right, let's do that again, only with more. What are our dimensions? 2 by 3 and a 3 by 3. Can I multiply these?
Yes.
What will I get when I'm done? So I'm going to start and
How do you know it's going to be 2 and 3?
the outside two numbers. These numbers here. That made it really messy. Okay, I'm going to start by making, and I'm going to have to put some work in here, that's why it's so big. 2 rows, 3 columns. That's going to be my answer. 2 rows and 3 columns. And I'll put all my work in there so that you guys know where I got the numbers from. So this would be first column, this would be second column, this would be third column. We've got first row, we've got second row. This is kind of like the distributive property. Okay, we're going to do the first row by the first column. I'm going to start there. First row, first column. 5 times 3 plus, then I switch to the next numbers. 1 times 1 plus 2 times 5. First row, first column. I said this is kind of like the distributive property because now we're going to do first row, second column. So you're taking the first row to each column. So first row, second column, we're going to do 5 times 1 plus 1 times negative 2 plus 2 times 0. Now we're gonna do first row, third column. And that's gonna go in the spot of the first row, third column. 5 times 2 plus 1 times 4 plus 2 times -1. If you have questions, you're going to stop me and ask, right?
Mhm.
I don't know what that noise meant. What spot is this one right here? What spot is that? Second row, first column. So up here, I'm going to get that number by doing second row, first column. So I'm going to do 2 times 3 plus 0 times 1 plus 3 times 5. Then I'm going to do second row, second column. So I'm kind of distributing. I'm doing the second row with each column. Second row, second column. So 2 times 1 plus 0 times -2 plus 3 times 0. And then I'll do second row, third column. 2 times 2 plus 0 times 4 plus 3 times -1. Now all you have to do is multiply and add them up. And we'll get our 2 by 3 matrix here. Oh. Let me put it up. So I'll add all these. I'll get 15 plus 1 plus 10. That's 26. 5 minus 2 plus 0, 3. 10 plus 4 minus 2, 12. 6 plus 15, 21, 2. And then four minus 3. Good. Okay, so multiplication might be one thing that might take a little bit less time to do on the calculator. Maybe. Unless you get a question like C. Could you type that in your calculator?
Nope.
So we do have to know how to do it by hand. All right, so for C, let's check our dimensions. We have a what by what? 3 by 3 times a 3 by 1. Can we multiply them? What will we get when we're done? So we will have 3 rows, just 1 column when we're done. That's what we'll have when we're done. So we're going to take our first row, multiply that by our first column. 3x plus -2y plus 5z. So could I add those numbers together? I can't because of the x, y, z. So this is a matrix that has an algebraic expression in the first spot. It looks like it has 3 spots, but it doesn't. It has 1 spot right there. Because matrices don't have like plus and minus signs in between the elements. This is 1 element. All right, how about my next one? We've got second row, first column. 4x plus 0y plus z. And the third one, third row, first column, x minus y plus 2z. And does that look like maybe kind of like what we were doing last chapter with the systems? Yeah, this is why we're learning this, because we're going to apply it to that next week. Not today, though. We're just learning procedures today. What's the next question say? Yay! Let's learn how to do it on our calculator. So when you turn on your calculator, the matrix button is in the first column, like 4, 5, depending on not the top button or not, 4 or 5 buttons down. Second matrix. Go ahead, second matrix. And there's some choices across the top, but we have to tell the calculator the matrix that we want to do something to. So go to Edit. And then we'll all choose matrix A. You really can choose any of the matrices that are available, but let's just all do the same. Matrix A, hit Enter, and it'll say, what dimensions do you need? So the first matrix is a what by what? 2 by 3? You hit 2, enter, 3, enter. Oops, I didn't do that though. 3, enter. 2, enter, 3, enter. Then when you hit enter for each number, it goes across the row, then it drops down and goes across the row, and then it drops down. So you don't really have to like keep looking at your calculator. That's the way it goes every single time. If you want to just hit enter in between each one. -2, 4, 0, -3, 0, 8. Thank you. Okay. So we've entered in matrix A. Now let's enter in matrix B. So go back to matrix, second matrix, go over to edit, and let's change B. So let's change number 2. And it needs to be a what by what? 2 by 2. And we'll type in 1, -1, 2, -1. Now what are we trying to do with matrix A and matrix B? We need to multiply them. So to do that, go to your calculation screen, like second mode, the click button. So you're in your calculation screen, everybody there? All right, so this is where we're going to calculate the product. Second matrix, now we can just choose matrix A. Enter. It is not necessary that you need the times symbol. You can if you want, or you can just put the two matrices next to each other. So now we need which matrix?
B.
Matrix B, so I'm going to choose B, number 2. And then what do we do? Hit enter. Why does it say that? Because you forgot to check that.
I was going to ask that, because I put that down. I started on it, and I'm like,
Good.
why are we using a calculator?
Well, I want you to learn how to use your calculator and see what happens if you don't think about things ahead of time. You can't actually multiply these because what are we supposed to check first? 2 by 3 and a 2 by 2. You can't multiply them. So you write undefined. But it was good calculator practice. So what should we do before we do question D? All right. So we got a 3 by 3 and a 3 by 3. Can I multiply those? What will I get when I'm done? All right, you try it. See that you can get the correct answer using your calculator.
do it.
You have to do the rest, multiply by hand.
Oh, yeah, okay.
Do you not have, you don't have to count?
That's over there.
It's probably usable now.
Okay.
I'll go sure if it wasn't. I forgot about that. Yeah, if you're doing this by hand, you should still get the same answer, but I would encourage you to learn how to do it on the calculator. So when you have a quiz next week, part will be on the calculator, part won't. And there will be a question like multiply it without the calculator. So you need to know how to do it, practice it. Unless it says use a calculator, practice it without. Okay? If you have questions about yours individually, please just call me over. Otherwise, the assignment is on your orange sheet, and I'm going to put it up here in like 2 seconds.